There are so many misunderstandings about the role topology plays in the psychoanalysis of Jacques Lacan that we need a new way to think about both topology and Lacan. What attracted Lacan to topology was something natural, something obvious, at least to him. So it would be good for us to have the same sense to turn the tables and make us, instead of asking why, ask why not. Many of us have gotten off on the wrong foot because there is a lot of disinformation out there. Some people say that topology is a rubber sheet geometry, which in the case of the topology that Lacan uses is entirely untrue. Topology doesn't begin with the Königsberg bridge problem. It doesn't exactly equal set theory, and it isn't just about Mobius bands or Borromeo knots. In fact, it's about things you can't see but still experience as visible, since to be able to see a truly two-dimensional form, you would have to add a dimension to look with, and that would make it technically a three-dimensional form. With nothing to look at, you really have to put your imagination to the test. We can't see projective geometry's forms, but we can model them as long as we make the lines of sight, our sagittal incursions, a part of the solution and not just more of the problem. Thanks to a psychologist, Stephen G. Rosen, now retired, I've been able to develop a clear graphic version of something Lacan uses in Seminar 13, The Object of Psychoanalysis, and elsewhere. Roughly speaking, it authorizes us to make a distinction that is not totally proper in terms of mathematics. But since both Lacan and Rosen use it as an analogy, I take the liberty of repeating their sin. This is about the problem we have with topology in general. We see some figures, such as the torus, that seem self-evident and unproblematic. We see others, like the cross-cap, which require us to imagine something that can't happen, a flow of a surface from an inside to an outside. Then we have the famous Mobius band, where we think we can see a twist, but when pressed, we can't see it at any particular location, undermining our visual confidence. Thanks to Professor Rosen, who duplicates one of Lacan's drawings in Seminar 12, Crucial Problems for Psychoanalysis, I can distinguish between an ordinary torus, which we find in such forms as donuts, bagels, and bicycle tires, and the torus that Lacan uses to describe basic functions in psychoanalysis. With the first kind of torus, you take a tube, bend it over until the two ends meet, add a little glue, and voila, you have a torus. This is nice enough if you need a donut, bagel, or bicycle tire, but it is not the same as the torus of projective geometry. This has to be drawn in such a way that the ends of the tube are arranged in what we would call a nonorientable way, not facing each other, but facing in the same direction, if that makes any sense. To simplify matters, I will call this a 2D torus to indicate that it is a type of non-orientable 2D manifold, and I hope this satisfies any mathematicians who may be watching. To understand how Jacques Lacan uses topology, we have to be familiar with a diagram known as the fundamental polygon. This is what mathematicians use to describe surfaces in terms of their construction and behavior. It's not exactly a picture or folding diagram, it's more of a movie script. Lacan's favorite fundamental polygon is that of the torus, and he draws it opposite to the ones shown here. Starting with the upper right-hand corner, Lacan's fundamental polygon of the torus expands out with two vectors moving simultaneously from the corner, then converging simultaneously to the opposite corner at the lower left. Lacan labels the corners in Seminar 14, The Logic of Fantasy. Repetition and sublation are the corners to care about, since if we can solve the mystery of distinction and convergence, we will be addressing the problem Freud faced in his failed project of the inverf, of finding a scientific psychology in the sequence relation of perception, interpretation, and action. This coupling of the red and blue vectors is not always obvious, and it's not the case with a 3D torus, where the blue vectors move together, then the red vectors. This makes the torus fold in on itself in two separate steps. We call this surface orientable because anything we might draw on it can be moved around without inverting or flipping. In other words, when the tube is folded and glued, the ends are oriented in the same direction. A cut we would make at the join would not reveal anything unusual. In a 2D torus, you get the same thing, but the blue and red vectors move together, first to create two opposite corners, then to close off the shape as two more paired red and blue vectors converge at the opposite point. The 2D torus is, like the 3D torus, self-intersecting, but the 2D torus is what we call non-orientable. That means that there's a twist in it that we can't see in the 3D version. So what does this twist feature do exactly? Welcome to the 2D space of the projective plane. All of the forms within this plane are similar in that they all involve this twist of non-orientation. Let me use the figure called the crosscap to show how this works. Imagine a bowl that we need to close off. Instead of finishing it with an inverted version of the bottom half, we start at the equator and make a twisted fold that is impossible to construct in three-dimensional space. We would have to fold the left side over to the right and the right over to the left. To do this, we need to create a Mobius band structure so that it will seem that the inside flows to the outside and outside back to the inside. But remember that there is no inside or outside in 2 dimensions of the real projective plane. So this flow takes place without any real contradiction. The non-orientation is something that bothers only observers who try to look at it in Euclidean 3 space. Why does Lacan use a fundamental polygon to talk about non-orientation? The short answer might be that it helps us resolve the argument he says we should all be having with René Descartes. When Descartes says, "I think, therefore I am," we can use the fundamental polygon to make a kind of rebus expression, then show how Descartes is wrong when it comes to human subjectivity. Lacan's argument runs like this. Descartes would be okay for a world of donuts, bagels, and bicycle tires, but human subjects live in a world where they experience the real in the form of trauma. They need toruses that are not Euclidean but projective to show how non-orientation works as a structure of the real, of the uncanny things we can't explain. To prove this, Lacan inverts "I think, therefore I am" directly into "I don't think" and "I am not." He folds the torus in a twisty way so that the result is a minus phi of non-orientation, something that is the result of structure, that is to say, of necessity arising through what appears to us to be sheer chance. We think we make conscious choices, but this structure is there working all the time in the background. In Seminar 13, The Object of Psychoanalysis, Lacan shows how you can find Mobius bands in the torus that you can connect to make a Klein bottle. In truth, topology allows self-intersecting and non-orientable forms to morph into each other with ease. It's just when we try to visualize these transformations that we have problems, and artists throughout the ages have directly taken on the problems of non-orientation. What I want to do next is show a simple way to construct a torus so that it will feature non-orientation and the fundamental polygon, and hopefully confirm what painters have for centuries been telling us about non-orientable space. The aim is to be able to see nonorientation as something not only common in everyday life in cultural practices, but essential to subjectivity itself. Just a quick reminder of how things work in the kind of torus you can eat and put on your bicycle. Imagine a plane with two sides, a heads and a tails, which moves through a full 360-degree circuit. As it finishes up the full cycle, it arrives back at the starting point. Between the finish and start position, the space inside reveals how the heads side of the plane meets up with its reverse side, heads versus tails. If we could position ourselves inside this tiny space, the view to either side would be of both sides of the coin, tails to the front, heads behind. The polarity of the tube does not change. Let's try the same trick with the projective or 2D torus, which intersects itself without making a full 360-degree turn. This means that the same coin will travel a full circuit without making a complete flip, heads to heads. Instead, it will arrive at the finish line in a heads to tails position. Note that we are looking at the back of the coin as it moves through the torus tube, and we see it flip to heads as it rounds the 180-degree bend. The space we imagine between the starting position and the finish line has an inside view of the tails, the back end of the starter coin, but the finish coin is also tails when we flip open the space from the inside position. If you have an observer outside of the torus, it must be a 3D torus. But what if you move the observer inside the torus? We know exactly where we have to place this space invader. It is exactly between the two blue disks, the place in the torus that is analogous to the twist of the strip of paper that turns the flat strip into a Mobius band. From this front row seat, the observer sees the one thing that makes the Mobius band a Mobius band. For the torus to become a torus, the observer has to be between the two plates that join the tube to itself. That's where it all happens. An external observer would come in from the sides to the middle, but an internal observer has to do something trickier. To be an observer without requiring an extra dimension and thus violating the rule of two-dimensional topology, the observer has to be inside the inside. We could say that this viewer is physically impossible, but theoretically he's necessary, as a kind of Janus figure who sees things that contradict each other in the same way that I think not and I exist not are not only contradictory as they stand, but radically contradictory in combination. Lacan has taken Descartes' familiar saying that I think, therefore I am, which seems to be so harmless and even so obvious, and shown how in fact it contains a radical problem. A speaking being cannot say I think without depending on the claim to be, and cannot of course say I am without speaking. These tautologies undermine the scientific value of the statement, since there is no way to confirm it that is not self-intersecting. One implies the other. There is no obverse to speaking and being, no off switch. Without the possibility of negation, speaking and being have no truth value, and if we reverse them, I think not and I exist not, and combine them in the same way Descartes combines I think therefore I am, we get not just one void, but a double void, a void that is a space that is different from itself because we can go around it in two different directions. We can watch countless fascinating visual effects on YouTube, but we are still on the outside looking in. Our view is stabilized by a frame and a screen. The 2D topology that Lacan takes to be real is something where we are on the inside. This makes it impossible to say that something is like a torus. The torus is what's happening, and there is no distance between us and it, no dimension of looking at, just a happening, an event. It is the real of structure. You might get a better sense of this by being aware of the immediacy of cuts and gaps. The most familiar case is the French philosopher Jean-Paul Sartre's example of someone who has promised to meet you at a restaurant, but who has not arrived. You go and look for, let's call him Pierre to match Sartre's example, but everywhere you look, every table, every other patron sitting down and enjoying a drink is not Pierre. Pierre is not there, with the same force as those who are there. This is the insider's perspective, positioned at the point where the gap, the missing element, is looking around but not finding anything to see. Because we can experience this kind of absence, we can in real life be a Janusian observer. We can experience contradiction or nonorientation from a front row seat. This is called alienation if we are neurotics inside the symbolic, expecting Pierre to act like a human being and fellow friend. Or we can call it an act that is defining us, pulling us into a tornado and taking us to the faraway land. If we are psychotic, even if only temporarily, like Dorothy in The Wizard of Oz, we can at least expect to see the same friends on the outside that we saw on the inside. This is the minimal comfort we get in the toroidal space of the projective plane.